Okay, in today's video we're going to talk about domain, range, and functions, as well as all these other key terms up here. So I wrote these up here because I want to make sure that you, by the end of this lesson, should know what each of these terms are. We're not going to formally define all of them, but you should have at least a working knowledge of what these are. So the first thing I want to talk about is domain. This should be review, but domain is simply your x values. So anytime you have a list of x values, your domain is just the x values. And range, very similar, is going to be your y values. Okay, so if I have some point, say 2, 1, remember that it's x comma y is how we define a point. So in this case, our domain is going to be the set of 2. And the range is going to be the set of 1. And we use these braces, these are little squiggly braces, to denote it's a set. So we have the domain, which is the x values. In this case, we have 2. And the range, we have 1. Now, we could have more options here. So let's do another example. In this case, let's have 2, 1. Let's go with 3, negative 1. And how about 2, negative 1? Okay, so I have 3 numbers, and we want to list the domain and the range. So our domain is going to be the x's. We have 2, 3, and 2. Now, a couple rules that you have to go with domain. First rule is you put them in order from smallest to largest. So the first number I see is 2, and that's going to be our smallest, and the 3 is going to be the largest. The other rule is you do not repeat terms. So I have 2 number 2's here, but I'm only going to write one of them. And then I have a 3. So even though I had 3 numbers, 2, 3, and 2, we're only going to write 2 numbers because there's only 2 unique numbers, the number 2 and the number 3, and we write them in order from smallest to greatest. So I have 2, 3. And these is our domain. We're going to do the same thing with range. Now there's no rule that says the domain and the range have to be the same size. You just have to list all the numbers. So in the range, I have 1, negative 1, and negative 1. So again, I'm going to have the same thing. These negative 1s are repeated, so I'm not going to use it. So I have 2 numbers, 1 and negative 1, that are unique. And I'm going to do the smallest first, so I'm going to use the negative 1 first. And then I'm going to use positive 1. So the range, or our y's, we had 3 numbers. And we're going to list the negative 1 first because it's smaller, and the 1 positive second. So our domain for this 3 set of numbers is 2, 3, and the range is negative 1, 1. Okay? Now, a relation is anything that relates one set to another. So in this case, we're talking about x and y. So as soon as we have a way that the domain relates to the range, we have a relation. And the way a relation looks like in a point form is that you have a point. So as soon as you have one single point, you have a relation. The only way you cannot have a relation is to have no points whatsoever. So almost everything we do is going to be a relation. Now a function's a little bit different. So we're going to look at a function in a minute. Before I do that, I want to talk about mapping. You've seen mapping before. Mapping looks like this. You have 2 sets here. One is going to be the domain, and the other is going to be the range. And sometimes we call these input and output. Okay, so input and output, this is another name of x and y. So input and x values and domain, those are all the same thing. And range, y values, and output, those are all the same thing. So if you see input and output, that's the same thing as x and y. It's the same thing as domain and range. So let me put x over there, and I'll put y over there. So we got x and y. These are all the same thing. So we're going to talk, I'm going to use inputs and outputs, but remember, these all mean the same thing. So we'll use the same set of numbers. You're going to write the same set that you had here. So I had 3 numbers, 2, 3, and 2. We don't repeat numbers in mapping either. And they have to be in order from smallest to greatest. In this case, we'll do smallest on top. So we're going to use the numbers 2 and 3. 2 goes on top, and 3 goes on the bottom. And then we do the same thing with range, except we're going to have the smallest numbers on top again. So negative 1 and 1. So even again, like I said a minute ago, we have 3 numbers here. We don't use repeats, and we put the smallest on top. So we're only going to use the individual unique numbers, which is negative 1 and 1. Now we use the points to do our mapping. This says that we're going from x to y. So I need to draw an arrow from 2 to 1. So from 2 to 1, there is a relation. Another relation exists from 3 to negative 1. So from 3 to negative 1, there's a relation. And then the last relation exists from 2 to negative 1. So from 2 to negative 1, there's a relation. So I have 3 relations. denoted by the 3 arrows, and I had 3 points. The number of points and the number of arrows should be the same, because each arrow is representing one relation, unless you have repeated a point, in which case then you won't see it appear twice, because it'll be the same arrow. So now we got to talk about the function. A function is defined for every x value there is exactly one y value. Or for every input, there is exactly one output. Okay, so we're looking for any x's that have more than one y associated with them, and we see one right here. So I'm going to change the color, and this is our problem right here, because this too has 2 arrows, one that's going to -1 and one that's going to 1. We can see it up here, because this has 2 different 2's with different y's associated with it. So as soon as you see this case where you have an input that goes to 2 different outputs, this is not a function. Okay, the 3 is fine because the 3 has only one output. So we can look at some other cases here. Let's say that these are just random numbers I'm drawing. And let's say that I have this case. This one has one number 2. This 2 has one number 3. This is an example of a function. Now the other case you sometimes see is this. This case I have the number 1 goes with the number 3 and the number 2 goes with the number 3. This is also a function, because this 1 has only one number, 3, and this 2 has only one number, 3. So even though we use the 3 twice on the output, the inputs have exactly one output. They just happen to be the same output. So this case where the arrows converge is okay. It's when they diverge, like they do in the first case that we looked at, that it is not a function. So this is an example of not a function, and these are example of functions. And if you're ever not sure, you go back to the original definition. For every input, there is exactly one output. For every domain, there is exactly one range. Or for every x value, there is exactly one y value. So that covers function, that covers mapping, that covers input, that covers output. On the worksheet that we're going to practice, we might give you the same information, but this time we'll put it on a graph. You should be able to tell me what these points are, 1, 1, 2, 2, in which case then you can go ahead and make your mapping. You should be able to tell me the domain, you should be able to tell me the range, all of that from this simple case. If you have any questions, please make sure you ask.